Lesson 123. This is our final lesson of our Algebra 1/2 textbook, and the title is Numerals and Numbers and the Subsets of Real Numbers. Now, real numbers can be broken down into many different categories, or subsets. And the first two are rational numbers or irrational numbers. A rational number can be expressed as a ratio, and a ratio is just another word for a fraction. So if we had the number 17, 17 is rational because it can be written as 17 over 1. If we had negative 3, that's rational because it could be expressed as negative 3 over 1. What about negative 1.5? Well, negative 1.5, that's 1 and 5/10. Negative 1 and 5/10. That's the same thing as negative 3 halves. So that's also a fraction. So negative 1.5 is also a rational number. Now, an irrational number is a number that cannot be exactly expressed as a ratio. So a number like pi is the first one that comes to many people's mind, because pi is equal to 3.14159, and so on and so on and so on, and there's no pattern. It just keeps going and going and going, so pi is an irrational number. If we had a number like, let's say we had 1.732415161721, and there was no pattern ever in here, then that's an irrational number, because there's no pattern, or the decimal never ends. The square root of 8. The square root of 8 is another example of an irrational number. And the square root of 8 is an irrational number because it doesn't have a decimal that ever ends. Let's look at some more subsets of real numbers. Now, rational numbers can be broken down further. They can be broken down into counting numbers or natural numbers, which are like 1, 2, and 3. The dot 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 means we just continue that pattern. So 1, 2, 3, 4, 5, 6, 7, 8, 9, just keep going and going. Whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on and so on. So the only difference between counting numbers and whole numbers is that whole numbers include 0, counting numbers do not. Integers are defined as whole numbers and their opposites. So we've got negative 3, negative 2, negative 1, 0, 1, 2, and 3. And we can see the pattern continues into the negatives and into the positives. And those are integers. Let's look at a couple questions. To which set of numbers does negative 7 belong? Well, if we consider this question, the first thing we have to do is say, is this a rational number? Can it be written as a ratio? Or is it an irrational number? And if we look at this, this must be a rational number, because negative 7 can be written as a ratio. It can be written as negative 7 over 1. If it's a rational number, we need to consider, is this a counting number? Is it a whole number? Or is this going to be an example of an integer? Or is it going to be more than 1? Well, negative 7 is not a counting number, because counting numbers begin with 1. It's not a whole number, because whole numbers begin with 0. But it is an integer. It is an integer because integers include whole numbers and their opposites. So we've got our two answers. To which sets of numbers does negative 7 belong? It belongs to rational numbers and integers. Lesson practice will be on page 393. Make sure you've got your notes complete, and I'll see you during our next class.